Good morning, friends. I am E. Nirmal, Assistant Professor working in the Department of Civil Engineering, Government College of Engineering, Dharmaburi. Today, we are going to see about various disasters that occur in India, the case study of these disasters. First one, landslides. Landslides are most occurring geological hazard in the world. These causes injuries, loss of life, damages to building as well as properties, and it affects a large number of resources. Landslides are the movement of mass of rock or debris over land under sea. Landslides occur when the gravitational force on the land mass along the slope exceeds the resisting force like friction. That is, when the self weight of the rock or the mass exceeds the resisting force, frictional force along the slope, the landslide occurs. The main causes of the landslides are gravity, sharp change in groundwater level, earthquake, volcanic eruption, and unscientific and unsystematic construction on the hilltop. A map showing subdivision of terrain in a zone that has a different likelihood that landslides of type may occur are known as landslide hazard zoning. Usually, landslides are predictable. With the help of satellite imageries and GIS map, scientists are nowadays able to pinpoint the possibility of the landslides anywhere in the world. And then it generally requires an understanding of the slope process and the relationship of the process related to geomorphology, geology, hydrology, climate, and then vegetation. So, landslide hazard zoning is a map. It will divide the landslide prone hill terrains into different zones according to the relative degree of sustainability to landslides. These zones are delineated based on geological, topological, and anthropogenic factors. These factors include lithology, soil, slope, drainage, element, land use, etc. So landslide usually based on the geological, topological, and anthropogenic factors. Geological factors includes the types of soil, fault zones, slopes, etc. Topological factors includes drainage, contour maps, and anthropogenic factors includes land use, climate change, and hydrology. The application of the zonation. It helps to decide the land use capacity of an area. It helps us to decide whether we can use the land for vegetation or construction or any other purpose. And it also shows the risk to the current land use development. It also shows the area vulnerable to landslides. Based on its surveys, it helps us to predict the future landslides and damages. Methodology of making the landslide hazardous zone. Remote sensing and GIS are the main two methodologies adopted for landslide hazard zoning. Usually, remote sensing data is used in the form of satellite images. GIS software is used to interpolate both the satellite data and base map to form hazard zonation. Usually, in evaluating landslide hazard means the future slope failure occurrence as a result of some geometric and geomorphic and hydrological situation that leads to past and present failures. Based on these assumptions, it is possible to estimate the type, frequency of occurrence, extent, and the consequence of the slope failure that occur in future. The satellite data is georeferred and rectified with the base map of the steady area. First, we are going to take the map of the particular zone. Then we will do georeferencing and rectify it and make it as a base map for steady area. Base map is prepared by use of topo-sheet. Base map is imported to the software and converted into its software data format. Geocoding and georeferencing is done to generate the base map in the software format. The segmented maps are digitalized in respective of domain of area, contour, and then drainages. Then DME, that is digital evaluation map, is prepared after interpolating the contour segmental data. It is analyzed by the spatial filtering and the slope maps are derived. From this, the flow direction and flow accumulation maps are also prepared. Generation of hazard zonation map. Satellite data are imported and georeferenced with the base map with the help of the software. Then this data is then interpreted by image interpretation key and pre-occurred landslides and land hazard zones are located. The slope map layer, flow map layer, drainage layer are added as a data to predict the landslide prone zones. So the complete quantitative landslide hazardment, which includes spatial probability, that is the probability that the given area is hit by the landslide, temporal probability, that is the probability that the given triggered event will cause the landslides, size and volume probability, which includes the probability that the slide has given the size and volume of the mass movements, a runout probability, the probability that the slide will reach certain distance down the slopes.